OpenVINO is already helping you perform inference, execute full GenAI pipelines efficiently on multiple devices and more. And here is OpenVINO Physical AI. Yes, OpenVINO can now power your robots. Physical AI is the natural next step for AI. We would like to bring the intelligence to the edge devices into the physical world. And there are, of course, many challenges. Please take a look at my other video explaining the various models architecture for imitation learning. Assuming you have used the Physical AI Studio and you already have a trained model, let's talk about the challenges to deploy such a model, and then I'll show you OpenVINO Physical AI. The model you've trained is controlling the motors, actually servos, of the robotic arm to perform the task it was trained for. It sounds simple, but getting motors to move correctly is actually quite hard. You have to account for jitter in the joint, noise from the sensors, and the fact that context changes everything. Simply commanding moving joint 3 to 45 degrees is not enough. The torque and power required to execute that movement differ dramatically if the arm is holding a 5-gram object or a 5-kilogram one. The good news is that this is a solved problem. Robot operating system like ROS2 sits between the AI model and the hardware, handling all of that complexity so the model doesn't have to. But even when we put this aside, there are many other challenges. First one is the speed. Robot operates in real time, which means that the model has to be able to supply the next command in a matter of tens of milliseconds, and these models are heavy. The second challenge is continuity. A model like ACT generates a chunk of actions, say the next 100 steps, and the robot begins executing them, but small errors accumulate along the way, and the model must continuously compensate. So the next chunk, let's assume it will be generated after 50 steps, has to blend seamlessly into the ongoing motion. This creates a complex, never-ending feedback loop just to maintain smooth, stable movement. Many times, you need your robot to perform multiple tasks. If you have an ACT model trained to do task A and another model to do task B, you sometimes need another model, probably an LLM, to decide between the tasks, understanding the context and deciding what to do next. Or you want the system to be able to accept vocal commands and decide another model. So, multiple models running in parallel. There are, of course, many more challenges, and these are the reasons we built the OpenVINO Physical AI. OpenVINO Physical AI is already powering the Physical AI Studio. So first, let's talk about training. You can use the studio for all the process of connecting the environment, robots and camera, data collection and training, or you can do it manually yourself using the API. Let me show you how. Navigate to Physical AI Studio, link below. This is how to install the studio. Please check my other video, or you can do it using the API, the training, benchmarking, and more. I'll go to the library. I will install from source, clone the directory, go there, create a virtual environment, and install. I don't need the extras. All set. If you'd like to execute training, you can just copy the code. I will bring over a ready data set from the robot repository. I'll remove the training part and run. The data set is here. You can explore it or even play the video of all the episodes. You can see the 2 arms recorded. This line is the actual training. This is the code if you'd like to benchmark. And once you have the model trained, you can export it from the checkpoint to your preferred backend, Torch, Onyx, or OpenVINO. And now to performing inference using the OpenVINO physical AI. The easiest way to go is to get a deployment package directly from the studio with a model already in OpenVINO format and all the code you need for using OpenVINO for inferencing the model. If you are not using the studio, the first step is to get the model, the policy, and convert it to OpenVINO format, as you can see here. Make sure you have the model and the metadata files in place. Get the inference package from the library and load the model, or the way we call it here, the policy. Now, it is important to understand that this is not a one-time inference. It is an ongoing loop between the policy and the robot's physical position, or in our world, observation. So we start with a clean observation and we reset the policy. And we are implementing a loop of actions generated by the policy based on the current observation until the policy indicates that we are done. Pretty clean API in the OpenVINO tradition that can give you both the performance and the flexibility you need, for example here, to run only 1,000 actions and benchmark the latency. OpenVINO Physical AI. Let OpenVINO power your robots. Try it out.